Before I start, what is that we learned in the last class? Does anybody remember it? Visali, Datta, Bhavesh, Aryahi, Sundara, Anika, anybody? What did you do? What did we do in the last class? Somebody has to help me recall. Otherwise, I have shorter memory than each one of you. Anybody? Nobody remembers? Yes, Datta, go ahead.
We do trig identity.
Trig identity was in the SAT class. I'm talking about the Algebra 2 class.
No,
So,
we did transformations.
transformation. Okay. So, we talked about functions transformations. And what did we cover in the last class? Ipsa, what did we cover?
Transformations.
Function transformations. And as part of transformation, what did we cover?
Up, right, up, down.
Shifting of functions. You have a function and you change something to it, and how that change makes the function shift. That's what we talked about, right? We talked about shifting. So I'll just help you guys recall. Did I do such a bad job? Nobody remembers what we did in the last class? Aryahi, Anika, Bhavesh, Vasundhara, Datta, Vishali. Did I do that bad a job? Nobody remembers me? Nobody remembers what we covered? And I'm looking for feedback because that will help me get better at what I do. So that's what I'm asking. Nothing against you guys. Okay? I always look at how do I become a better teacher? How do I become more relevant to you guys? That's my goal. Yeah? Okay. So without doing much of a preaching, we talked about how does functions transform. Yeah, Nanya? Is everybody able to hear me okay? Is everybody able to see the dance of my fingers okay?
Yes, sir.
Okay, wonderful. So, I was just checking if the whole board is visible to you all. And I would still recommend to keep your videos on if that's not that big a problem. So that it's, this all is dealing with cold. So am I. Here in the classroom also it's pretty cold. So I have turned on the heaters. Okay, coming back to a serious discussion. So we talked about shifting of functions. And what does it mean is, if I have a function f of x equal to, let's say, x plus, let's say 5x. This, what it does is, it's a linear equation, right? So here I can relate this to y equal to 5x. And it will draw a line for me. So y equal to f of x equal to 5x. So it will draw a straight line for me. I'm not saying that this is the correct line, but I'm just saying this will draw a line for me. Because it's a linear equation. When I add let's say a 2 to it, what happens is the whole line shifts upward by that many points. So 5x, look at this one, x and y or fx, whatever you call it. When x is 0, y is 0, x is 1, y is 5, x is 2, y is 10. So when x is 0, y is 0, so it's here. It's not going through this. X is 0, y is 0, this is 1 point. When x is 1, y is 5, second point. When x is 2, y is 10, this point. This was my line before. When I add a 2 to it, what we saw was 0, it's 2, 1, it's 7, 2, it's 12. What happens is 0, it's 2. When x is 0, y is 2. You will see that this has shifted up. Every point has moved by this many points. So this is called shifting of function. Same thing if you have any equation. I'm giving a linear equation. Even if f of x was a quadratic equation and you say in place of x I will have x minus 2, then if f of x was x squared and this was the graph coming before, if when I do a minus 2 here, I'm actually shifting this by 2 points. Whatever is this thing subtracted, when you are subtracting here, you are making it move to the right. When you are adding, you are making it move to the left. This is what we did in the last class. Does it help you guys recall it? Vasundhara, Datta, Aryahi, Ipsa, Bhavish. Everybody okay? Nika okay? So this was on shifting. Whether we are shifting it up or down or shifting it laterally. You add something as a constant, you are making it move up. When you subtract, you are making it move down. When you are in place of the variable, if you change it to x minus 1, you are making it move right by 1 point. Everything by 1 point. When you do plus 1, you are making it move to the left. So that's the thing that we have learned in the last class. Today we are going to talk about reflection. Okay? So you have a function. How does the function reflect across the x-axis or y-axis? That's what we are going to cover today. Does that sound okay? Reflection. Now, what does reflection mean in practical terms? Bhavish, Aryahi, Vasundhara, Datta, Dishali, anybody? Ayusha. What does reflection mean?
Reflection means like it's like when you look at a mirror, it's gonna show you like the same thing back. But in math, it's like 1 point.
Okay. So let me give you a pictorial way to relate to it. Let's say I had this guy is probably heading towards my life. So I had a coordinate plane, and let's say I had an equation that is graphing a parabola. If I'm talking about reflection across x-axis or y-axis, what I'm talking about? When I'm talking about reflection across using against x-axis, I'm talking about it becoming this. If I'm talking about reflection across y-axis, I'm talking about this. Yeah? So this is one form of reflection and this is another form of reflection. Again, it is across a reference plane, or you can call it a mirror. Here when you are talking about reflecting along y-axis, you are treating this y-axis as your mirror, so that you can see the image coming in this mirror. If you talk about reflection across the x-axis, you are treating x-axis as your mirror, and then it reflects. Does it sound okay, or am I making you guys more worried? Bhavish, am I making sense better so far? Okay, Aryahi, Ananya. See, I'm not talking about math, I'm talking about things that we do every day. It will be hard for me to believe that we don't see mirror. All of us see mirror, right? So what does mirror do? It just reflects our image or whatever comes in front of it. So here my mirror is x-axis and y-axis. That's what I'm trying to say. Now let's try to relate to it. So that way it will sound more relevant to you all. Let's say it's time to throw these 4 markers. Okay. See, you guys were not turning on the video, and that's why this Ali said, okay, while I want to be the odd one out. Yeah. That's okay, but that's fine. Okay, these are the two x and y axis. Okay, this is my x axis and this is my y axis. I am putting some points 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Okay. Then here I have, let's say 2, 4, 6, 8, 10. Here I have minus 2, minus 4, minus 6, minus 8, minus 10. Give me 10 seconds, I'll be back. Mitu, आप क्लास में क्यों नहीं बेटा? Come to the classroom. Okay, so I have this coordinate plane. Let me pick up an easy equation. Let's say our function f of x equal to x squared. I am using the same easy one. Or let me not use x squared always. Let me say 2x squared. I want to see what this function plots for us. So no fancy stuff. I'll just create a table with x and f of x. Y axis is nothing but my f of x. This is where I am plotting y values. Let's see what happens here. 0, 1, 2, minus 1, minus 2. These are the options I am picking for x and see what is the corresponding value for y or f of x. When x is 0, 2 into 0 squared, that is 0. When x is 1, 1 squared into 2, 2. When x is 2, 2 squared is 4 times 2 is 8. When x is minus 1 squared gives me 1 into 2, that is 2. When x is minus 2 squared gives me 4 times 2 is 8. I have these points. You guys can see what I am writing in the corner, right? Maya, you have to be in the classroom. Okay? Maya, come to the classroom. So here, I have certain values of x and fx from this equation. Let me plot it. 0, 0 is 1 point. 1 and 2 is second point. 2 and 8 is the third point. Similarly, minus 1 and 2 is fourth point. Minus 2 and 8 is the fifth point. Let me join this. This has drawn a parabola for us. Yes, Sana? So, Sana, I'm just trying to help you catch up. We talked about shifting functions in the last class, or transformation of functions, in which first thing was shifting of functions. Now in today's class we are doing reflection. Okay, so Sanjita also has joined and you guys are a little late. So we are trying to understand what is reflection of functions. Okay, so what I've done is I took a function f of x equal to 2x squared. I plotted the value of x and fx. I derived the values in the table and I just plotted it. Now I want to see what happens if I, instead of saying 2x squared, if I say I find another function g of x as minus 2x squared. F of x equal to 2x squared plotted this parabola for us. I am trying to plot for another function g of x equal to minus 2x squared. So whatever I had here, I just multiply that with the minus sign. Is that okay, everybody? At least you guys know what I am trying to do. What happens, that will figure out. Yeah. Now I will create a same table for this also. This is x and g of x, which will be y. Okay. let's see what happens here. When x is 0, what happens? When x is 1, what happens? When x is 2, what happens? When x is minus 1, what happens? When x is minus 2, what happens? When x is 0, 0 square into minus 2 is nothing but 0. When x is 1, this becomes 1 square into 2, that is 2 minus of that, so minus 2. When x is 2, 2 square becomes 4 times 2 is 8 minus of that. When x is minus 1, so minus 1 square gives me again 1 times 2 is minus 2. When x is minus 2 square gives me 4 times 2 is 8 and minus of that. So I see these values. Let me identify those points. 0, 0 is 1 point. 1 minus 2, 1 and minus 2. This is my second point. 2 minus 8, 2 and minus 8 is my third point. Minus 1 and minus 2, minus 1 and minus 2 is my fourth point. And minus 2 and minus 8. What did you guys see? It created a mirror image of that, where your x-axis is your mirror. Ipsa, Myra, is it making sense? What did you see here? It just created a reflection of this using this as a mirror. You have an equation, you put a minus to it, you multiply it with a minus 1 and you saw a reflection across the x-axis. Did you guys observe the same thing? Vasundhara, Datta, Disali, Ananya, Sangita and Sana. Ariyahi? Everybody okay?
Yes.
Now, so we saw a function drawing something on the coordinate plane. We multiplied by minus 1 and we got another function that created a reflection of this one. Now, how about I multiplied by minus 1. Now I'm saying my function was f of x equal to x squared or 2x squared. I want to talk about another function, let's say k of x equal to, in place of x, what I will do is minus x, okay, squared. You guys are seeing what drama and circus I'm doing, right? You guys are able to relate to it? Myra, is it making sense? Or you are lost? It's not about you knowing it or not. I'm asking, is it making sense or not? Yeah, okay. Because we'll have some problem that we'll try solving. That is where whatever we know, we'll be able to apply that. And remember this, you are coming to the class always. Okay? That has to be a rule. Yeah? Yeah. And don't forget, we have to be on time so that we make mistakes all the time. Now coming to this one. So, same thing, I have another function with x and f of, here we have k of x. Let's see what happens. I'll take same values here. 0, 1, 2, minus 1, minus 2. When I put x equal to 0, what happens? This is 0 squared times this 2 is 0. When I put x equal to 1, it became minus 1 square of that is 1 times 2 is 2. When I put x equal to 2, it became minus 2 square of that is 4 times 2 is 8. When I put minus 1, so this became minus into 1, minus 1 square, again same thing. When I put x equal to minus 2, it's minus 2 into minus becomes 2 square is 4 into 2, 8. Now what's happening here is, I'm getting the same set of points, 0, 0, 1, 2, 2, 8, minus 1, 2, and it will again overlay the same thing. And this was not the right example. Okay, this was not the right example, because what is happening is, this guy is creating a reflection along the y-axis, but across the y-axis it is symmetric, so you are not seeing the reflection here. Okay, I will have to change this problem a little bit, and we will be able to witness this. So far what we have seen is, if you had a function you multiply that with a -1, you create a reflection across the x-axis. And this example that I took, that was not the right example. Let me give you guys another example, where we will see how it reflects across the y-axis. Is that okay? See, the problem is this guy is equally symmetric on both sides of y-axis. So even if you take a reflection of this across y-axis, it overlays it. Okay, it shows the same thing. Yeah. So this is not the right example. So what we will do is we will practice what we have learned in the previous class. Since it is here, that's what is creating problem. F of x equal to 2x squared. What I will do is I will make it, let's say, m of x as 2x squared plus 2. I will just make it move. I'm saying plus 2, meaning it will move upward, and then the diagonal reflection will do the same thing. So I will not do that. What I will do is I will say 2 of x minus 2 squared. Okay. So basically when I am doing -2, I am making it move laterally to the right. Yeah. So let's see what happens. Let's try plotting this one with x m of x. Are you guys okay so far? I'm just trying to move it laterally with whatever we have learned with respect to shifting, and then we will try reflecting it also. So two things you will be able to revise at the same time. Samrita, Sana, are you guys okay so far? Okay. So let's look at it. I'm just trying to practice the same thing that we have learned before. What happens when x is 0? 1, 2, minus 1, minus 2. I'm just picking up easy numbers so that it becomes easy for us. So when x is 0, I put here 0 minus 2 is minus 2. The square of that is 0 minus 2 is minus 2. Square of that is 4 times 2, 8. Okay. When x is 1, when x is 1, 1 minus 2 is minus 1. Minus 1 square is 1 times 2. When x is 2, this became 0. So this became 0. When x is 2, this is 0. So y will be 2 times 0 is 0. Now when x is minus 1, it became minus 1 and minus 2 became minus 3. Minus 3 square is 18 times 2. Minus 3 square is 9 times 2, 18. When x is minus 2, it became minus 4. Minus 4 square is 16 times 2, 32. Let's try plotting it. When x is 0, y is 8. When x is 0, y is 8. It's here. When x is 1, y is 2. When x is 1, y is 2. This is the second point. When x is 2, y is 0. Third point. When x is minus 1, when x is minus 1, this is 18. Somewhere here. When x is minus 2, is 32. Here, somewhere here. So this graph is coming this way, okay? And then if I put more values, if I put higher values of x, you will see that this comes this way. So now this graph has shifted to the right by this many points. Does it sound okay, Sundara, Naryahi, Anika? Yeah? So I have done nothing new today. I am just showing you that, okay, we had a graph, I subtracted from the variable x. That, since I subtracted, so it's moving to the right. That's what we saw. So now my reference graph is this one. Okay? This is the graph I'm talking about. And I'm trying to reflect on this across the x-axis. What I have to do is, whatever is the value I have, I'm saying I have another function called n of x, which is minus of 2x minus 2 squared. So whatever I had here, I'm doing a minus of that. So that means Whatever comes in this case, you are talking about minus of that. So let's put some numbers here and see the behavior of this one. X, n of x, and let's use the same values here. 0, 1, 2, minus 1, minus 2. When I put 0, x minus 2 square is 2, times 2, 4. 2 square is 4, into 2, 8, minus of 8. When I say x equal to 1, it becomes minus 1 square is 1, times 2 is 2, and minus of it. It's minus 2. When I say x equal to 2, this becomes 0, this will be 0. When x equal to minus 1, so minus 1 it becomes minus 3 square is 9 times 2, minus 18. And when I say x equal to minus 2, it becomes minus 4 square is 16 times 2, minus 32. So let's see what happens. So what it will do is, see, again we did a minus of the whole thing. We did a minus of the whole thing. What that will do? Myra, what will it do?
It will reverse out the annex numbers, put the numbers in negatives.
No, it converts everything to negative, but visually what it will do?
It will go the other way.
It will go the other way down. It will be downward actually. It will be creating a reflection across the x-axis. Correct? When you multiply with a negative number, whatever you have, if you try plotting it now, 0 minus 8. 0, x is 0, y is minus 8. It is here. 1 minus 2. 1 minus 2. It's here. It's here. 2, 0. 2, 0. Here. Minus 1, minus 18. So minus 1, minus 18, somewhere here. Minus 2, minus 32, somewhere here. So what you are seeing is, it creates a graph like this. So again, we took a function and we multiplied that with minus 1. It created a reflection of that across the x-axis. Does it sound okay so far? Bhavish, Arya, Ananya. So see, look at the summary of what we have done so far and compare that with the last class also. If you have a function, if you add a constant to it, you are making it move upward. You subtract a constant from it, you are making the whole graph shift downward by that many points. Every point moves by that many points. When you, in place of x, if you put up x minus 1 and square of that, that makes it move to the right. That's what we saw here. When you put this one, the graph was here before. When I put x minus 2, it shifted by 2 points to this side. Now, on the top of that, when I multiplied that by minus 2, this graph that had moved from here to here is reflecting across the x-axis. Okay? Now, in the same graph, if you have to reflect it across y-axis, what I have to do is, whatever you have here, you replace that with a minus. The variable, which is x now, if you make it minus x, you will see the reflection of that across the y-axis. This is the what do you call it? This is an assumption that I am making you guys believe. Let's see if that is the case. Yeah? If so, is that okay?
Mm-hmm.
You're making something interesting? Okay, so here, before I move on, Sana, Ananya, Dishali, Datta, are you guys with me so far or not really? A little bit, yeah? Am I getting anybody confused with whatever attempt I'm making? Vasundhara, am I confusing you, beta? No? Okay. Bhavish, okay? Yeah. Yeah. Okay. So now, what I'm saying is, if I had a function like this, function like this. We saw that by multiplying -1, it creates a reflection across x-axis, and we have seen that twice. Now I don't want to waste everybody's time doing the same stunt one more time. What I want to do is, I will say, I want to create a function k of x, where in place of this, I will say x, I'll change the x to minus x. Okay? I change the value, whatever variable I had here, multiply that with minus. Okay? Or let me, for the sake of simplicity, this is my variable, okay? That's what is making it move here. Let me see what I can do. X minus 2, whatever I had here, I'm putting a negative against it. Is that okay? Ultimately, it's just an equation, right? So, let's see what happens here. Let's put a table around it and see what is happening. X, and this is k of x. See, the only good news is, I'm not doing anything fancy. Whatever function equation that I'm talking about, I will just put the value of x and create this table and then try plotting it, okay? So, and whatever gets plotted, that will be our source for interpretation, okay?
Okay, so what if you just have like the thing, like the function? Do you just like plug in random numbers to make a table and
then plot it. So that will give me an intuitive view of it. Okay? So now, this is my new function, where what I have done is, whatever was my variable that was being squared, I put a negative against that. Because we saw that, okay, when I put a negative here, it reflects across x-axis. I'm saying, okay, fine, whatever is my variable, the input, let me multiply that with minus and see what happens. So now, when x is 0, what happens? X is 1, what happens? X is 2, what happens? X is minus 1, what happens? When x is minus 2, what happens? Now, when x is 0, so 0 minus 2 is minus 2 times this gives me, so when x is 0, 0 minus 2 is minus 2 times minus is plus 2, 2 square is 4 times 2 is 8. When x is 0, kx is 8. When x is 1, so 1 minus 2 is minus 1 times minus makes it 1. 1 square is 1 times 2. Okay? When x is 2, this became 0, this is 0. When x is minus 1, so minus 1 and minus 2 becomes minus 3 times minus is 3, square is 9 times 2, 18. When x is minus 2, this became minus 2 and minus 2 minus 4 times this becomes 4. 4 square is 16 times 2, 32. Let me try plotting it. When x is 0, y is 8. This is where the point is. When x is 1, y is 2. This is the second point. When x is 2, y is 0. This is the second point, third point. When x is minus 1, y is 18. Somewhere here. When x is minus 2, y is 32. Somewhere here. If I tried joining these points, where are these points? Let me pick some points. 0, 8. This is here. This is the point. Let me pick some interesting points, okay? I will look at different numbers so that I can portray it here. I would want to pick some points that are a little different. I will pick, let's say, x equal to 0. That gives me 0 minus 2, 2 square 4, 8. Let me pick x equal to 5. 5 minus 2 is minus 3, 3 minus 3 square is 9 times 2, 18. Let me pick, this is minus 5. Okay, minus 5 and minus 2 is minus 7, square is 49 and this is time 2 is 98. This is not working. Okay, x is, if I pick x equal to minus 3, it becomes minus 3 into minus 5 is 5 square, 25 into 50. This is giving me a hard time. When I put x equal to minus 2, this gives me 0. Okay. And then I pick x equal to 3. This becomes 3 minus 2 is 1, minus 1, square is 1 times 2. Let me try plotting these points. When x is 0, y is 8. So when x is 0, y is 8. This is 1 point. When x is minus 5, y is 98, somewhere up in the sky. Okay. When x is minus 3, it is 50. It has come down somewhere. When x is minus 2, y is 0. So it's coming here. When x is 3, y is 2. Okay. And okay. When x is, let's say, 5, it's not giving the right picture actually. That's what is my worry. Because I picked up an equation which is giving me larger values and they are not able to visualize that. Okay, let me do one thing. Let me just 1 second. Okay, I will rush through this. I want to paint this picture for you guys so that you guys can see that, okay, when you are multiplying with minus 1, what happens? When you are multiplying, when you are changing the variable to a smaller number, what happens? So I will probably use a simple equation. Let's say f of x equal to x square. I'm just using this one. So if that is the case, this is my 1, 2, 3, 4, minus 1, minus 2, minus 3, x square, x minus 1 square. I will use this one. Okay. 2, 4, 6, 8, 10, minus 2, minus 4, minus 6, minus 8, minus 10. So let's see what happens here. Where is my function right now? X, f of x. Are you guys getting tired of what I'm doing? Give me 2-3 minutes. I'll be able to plot this. Okay, I want to make sure that you guys have a right picture of it. When x is 0, what happens? When x is 1, what happens? When x is 2, what happens? When x is minus 1, what happens? When x is minus 2, what happens? X is 0, 0 minus 1 gives me 1. When x is 1, this becomes 0. When x is 2, 2 minus 1, 1 square, it's 1. When x is minus 1, becomes minus 2, square is 4. When x is minus 2, it becomes minus 3, square is 9. So if I plot this graph, 0, x is 0, y is 1 here. X is 1, y is 0, this is the second one. When x is 2, y is 1, it's here. When x is minus 1, y is 4, so it's here. When x is minus 2, y is 9, it's here. So this is the graph that I am plotting right now with this equation. Now what I am saying is, in place of x, if I replace this with a function g of x, where in place of x, I will say whatever I have here, I will put a minus sign to it. So here I have multiplied this whole thing by minus. So earlier we had multiplied minus here, that had created reflection across the x-axis. right now what we are doing is I am putting a minus against the variable. So in place of x, I am saying this whole thing is minus, and then we'll see what happens. Now, if I try creating a table out of this, x, g of x, 0, 1, 2, minus 1, minus 2, and see what happens. When x is 0, this is minus 1 into 1, 1 square, this is 1. When x is 1, this became 0, 0 square is 0. When x is 2, it became minus 1, and then times minus is 1, 1 square is 1. Now when x is minus 1, this became minus 2, into this is 2, square is 4. When x is minus 2, this became minus 3, sorry, minus 1 is minus 1, minus 2, plus 2, 4, yeah, that's fine. When x is minus 2, this became minus 3 times minus is 3, square is 9. Okay. 0, 1, 1, 0, 2, 1. Just trying to see 1, 0, minus 1, minus 1, 1 is square. 1 minus 1, 0 square. Okay, and then it's plotting the same points. That's what is bothering me. 1 and 0, 2. Am I picking the right example or not? That's what my question is. If I just put here minus x minus 1 square, what happens? If I'm just multiplying the variable with minus 1, what happens? X, g of x. I know you guys are getting tired, but I want to confirm that, okay, when x is 0, this is minus 1, the square is 1. When x is 1, this is minus 1, this became minus 2, that is 4. Minus, when x is 2, this became minus 2, and minus 1, minus 3, became 9. Okay, I think I'm getting it now. It's minus 1, so minus to minus plus 1, it became 0. And minus 2, so we can put 2 minus 1, it's 1. Let me try plotting this. When x is 0, y is 1. X is 0, y is 1. This is the point. When x is 1, y is 4, which is this point. When x is 2, y is 9, that is this point. Okay. When x is minus 1, it is 0, this point. When x is minus 2, it is 1. Minus 2, it is 1. Yeah, I think I am getting it now. Now if I join these points, what you will see is, for every point, there is a corresponding reflection here. Here it's 1 and 1, reflecting each other. Now this point, if you flip this point and this point are reflecting each other. When you look at this point, 1 and 1, so I mean you have to visualize this as an image. See, look at this one. This one literally flipped. So this one, if I flip this one, it will and flip this, and so basically I'm just trying to explain how you see this image, this and this reflecting each other, this and this reflecting each other, this and this reflecting each other. So this is probably not giving you the right example, but not giving the right view. So if you can try doing something with a radical function, right? F of x is, let's say, square root of x, and you go for g of x as square root of minus x, you will see the difference. So just this is an example, but what I'm trying to say is, the conclusion from this whole thing is that if you have a function, if you multiply that with a minus sign, it will reflect across x-axis. If you, whatever variable you have, you put a minus to it, meaning change the sign here inside, it will reflect it across y-axis. This equation that I picked up, probably that is not reflecting that behavior as intuitively as possible. If I would have picked up another equation where it was more explicit, it was being plotted somewhere here, then I was creating a reflection by multiplying the x with a minus, that would have given a more intuitive view of it. But at least conceptually, with respect to reflection, are you guys able to digest this or not at all? I'm just trying to think whether we would need another few classes, or this is at least giving you that starting point. If so is not looking convinced. Looking convinced? So the only takeaway here we have is that you can deal with a function and reflect it either across x-axis or across y-axis. And when you multiply the whole outcome with a -1, whatever you will get as a new function, that will be reflection across x-axis. If you only multiply the variable with a -1, you will see it reflecting across y-axis. Does it sound okay? So let's do one thing. We don't have much time in today's class, but what we can do is, let's look at one problem relating to this one and see if we are able to at least use this understanding for solving the problems. Okay? And what I would request is, you guys try doing this problem on reflection. Go to Khan Academy. For Algebra 2, you will see transformation functions, and try doing the unit test on reflection with whatever you have learned. Right or wrong, doesn't matter. Okay? Try using this concept of how it reflects across x-axis and y-axis, and see the problem that you have there. And are you able to do it by yourself, or you are having more doubts? So let me put a question here, okay, and see if you guys are able to at least wrap your head around this one. So this is my x and y axis. This is x axis, this is y axis. I have a graph which is coming like this. This is solid graph. Then I have another graph so this one is, so again, my struggle is with the drawing skills. I'm just trying to manage somehow. Okay. Okay, these are two graphs. I'm hoping that you guys can at least relate to it, that somehow they are related to each other. Maybe one of them is reflection of the other one. Does it look like that, or it doesn't look like that at all? Somewhat. At least this line here is somewhat mapping to this one. This curve that you see here is relating to this one, and this graph. Yeah? Can I assume that my drawing is somehow making you believe it? So this is f of x and this is g of x. So the dotted graph that you see is a g of x, and the solid graph that you see is plotted by f of x. The question says f is defined, or f of x is defined as 1 by 4 x plus 2 square, 1 by x plus 2 cube minus 2, what is the equation for g of x? And this is what we have to figure out, and here are the options, okay? Let me get you guys overwhelmed with all the options that you see and see if you are able to think through it at least. G of x equal to 1 by 4 x plus 2 squared, x plus 2 cube minus 2. Option B is g of x equal to minus 1 by 4 x plus 2 cube plus 2. Option C is g of x equal to 1 by 4 2 minus x cube minus 2. Option D is g of x equal to minus 1 by 4 2 minus x to the power 3 minus 2. So if I try making you guys believe that this graph, let me draw this little better. Okay, so this is g of x, the dotted one is g of x, and the solid one is f of x. And f of x is represented by this equation 1 by 4 x plus 2 cube minus 2. And you have to find out what is the equation for g of x, which is the dotted one. So which option sounds relatable to you? First one is g of x equal to 1 by 4 x plus 2 cube minus 2, same as this one. Second one is g of x equal to minus 1 by 4. So you have put a minus 1 by 4, so that makes this 2. So this one is same as this one with minus, whole thing being multiplied with minus 1. Option C is g of x equal to 1 by 4 2 minus x cube. So this whole thing is multiplied by minus 1 minus 2. Option D is g of x minus 1 by 4 2 minus x cube minus 2. So here what is done is option C and D is relating to this thing being multiplied with minus 1, this variable thing. Option 1 and 2 are relating to, first one is copy paste of this one, second one is minus times of this one, meaning it's talking about reflection across x-axis. So if you reflect this guy across x-axis, what will happen? This will come down, this will go up, correct? Now if you think about this, if you reflect it across x-axis, what happens? This guy comes down and this guy goes up, and it overlays this guy, correct? Look at my hand movement. If I am reflecting it across x-axis, what will happen? This will come down and this will go up. Does it look like reflection across x-axis or not? If I would reflect this guy across x-axis, so this guy comes down, see this is overlaying this one, and this guy goes up, right? When you're reflecting it, you are flipping it, right? This solid, does it look like this is getting reflected across x-axis? Now think about this. If I'm talking about reflecting this across y-axis, what will happen? I will reflect it across y-axis, so this will flip this way. This will, when this guy flips, it will come here. This is what we'll end up getting. So, but this is not same as this one. So this is certainly not reflected now. This is not certainly reflected across the y-axis. So wherever it's talking about reflecting across y-axis, that is not to be the case. This is certainly not the case. Because here you are multiplying by minus. That is how this whole thing is changing. So this is not reflected across the y-axis. So this one and this one I will rule out. Now between A and B, first one is just a copy of that. 1 by 4 x plus 2 cube minus 2. This is not the same graph. G is not the same graph as this one. So the only option that we are left with is this one. Does it sound reasonable or no? If so?
Yes.
No, I'm asking, how did I rule out the other three options? If I look at this one, 2 minus x. So basically it's getting multiplied by minus. That's how this thing is changing. And that will happen only when I'm reflecting this across y-axis. When I reflect this across y-axis, what will happen? This guy will move this way. So this will come here and it will be drawing like this. but this is different from that reflection. So this is certainly not reflection across y-axis. These two I will rule out. And the first one is same copy paste of this one. So we are not talking about the same graph any which way. So this is the option that we are left with. Here what you are seeing is this is getting multiplied by -1. That is how this whole thing became minus and this became plus. So we are talking about reflection across x-axis, and that is how you see the lever. If you look at this as a lever being rotated, it coincides with that one. Does it sound okay, Sanjita, or too confusing as the visual problem that we were seeing before? Bhavesh, does it sound okay, bro? Vasundhara? No? Ananya? Okay, so let me do one thing. I will just talk about one last problem and then I will let you guys go. I don't know whether you guys enjoyed this class or not. I certainly did not, because I was trying to give you guys the right visual of reflection across y-axis, but the option that I chose was not giving that intuitive view. So I'm not very comfortable, but let's see if you guys at least had some takeaways. So this question says that you have a graph, and this graph is coming like this and goes like this, and this function is f of x equal to x cube minus 6x squared plus 9x. Now what is the graph of, it says what is the graph of g of x equal to minus x cube plus 6x squared minus 9x. And then you are given options like option 1 is option 2 is, I'm not putting the numbers and all, okay, because I want you guys to think about it. Option C is like this. Did I do the option right? Be correct? No. Option B says you are coming from here. Okay. Option D is, and again I know you guys must be struggling to read my drawing, but be assured. Okay. So this is the graph of the function f of x equal to x cube minus 6x squared plus 9x, and we have to find out what will be the graph of g of x equal to minus x cube plus 6x squared minus 9x. And they are the four options. Without even looking at the numbers, what is that comes to your mind in the first place? Yes, Sana.
I think it's B.
You think it's B? And why you think so?
Because it looks like a direct reflection of
Around x-axis, right? Because the whole thing should multiply with -1. What you will get is minus x cube plus 6x squared minus 9x. So it's a reflection across x-axis. Now, so when you try to reflect it across x-axis, this guy will come down and this guy will go up. So here you have to have this thing here and this one coming down. When this guy comes down, this guy brings this portion of the curve also down. So this one is certainly not the case, because this hand has to be down, right? This is same as this guy. This is also same as this guy. So you are contemplating between this one and this one. But you will look at if you are turning this around. So yeah. This is also not the case, because this one is, when you rotate it, you will see that this line is going through this, right? This, when you rotate it, so this line, so it will be like this. No, let me not try drawing it. It will get you guys more confused. But first observation was that I am multiplying this whole thing with -1. That means I am reflecting across x-axis. So you have to visualize which one is relating to that. Yeah. So Sana, I think your interpretation was right, because when you look at the actual problem, reflecting this will get you an open end here, and then this will draw it here, and then this line crosses this way. Okay. I'm not sure if I'm able to depict this in the right intuitive way or not, but when you look at this graph and this graph, do you see this as being reflection here? Disali, Nanya, anybody? No? Okay. Alright, so this was just a jump start. I think we need to practice a little bit more. And I'll find out one sample equation where I can show you the reflection across the y-axis in a more intuitive way, because whichever example we picked up today, that was little not convincing, I would say. Yeah? Alright? With that being said, I'll let you guys go. Enjoy the rest of the evening. Enjoy the spring break. We'll meet again Thursday. Alright, bye bye. Okay.